there being a mirror somewhere. And even if we can't help but notice them, we do tend to take them for granted. You know what? It's time that we saw the truth behind the mirror. It's time for how connected experimental knowledge. About 5,000 years ago, mirrors were made of highly polished bits of metal, such as bronze, copper, and the super rich gold. In all cases, a mirror was a highly prized symbol of status and wealth. But most people were left out with that. And the reflective properties, compared to modern mirrors, it could be a big deal.
Now would be another great time to reinforce those behaviors that you want to see.
Early versions of this were kind of crude, but by the 16th century, glass artisans in the Republic of Venice became pretty good at what was called silvering. Now that's the process of coating glass with a thin layer of metal. The only thing, one of the metals used in this process is mercury, also known as the most toxic metal in the world. Then, in the mid-1800s, German chemist Justus von Liebig figured out how to use actual metallic silver in his silvering process. The way was now cleared for an age of safer and inexpensive mirrors. A mirror begins as a large sheet of plate glass. It's first cleaned with hot, demineralized water, and then the layering begins. First comes a layer of liquid tin, and then a layer of silver. So some manufacturers will use aluminum tin instead. In either case, these metals react with one another, and presto, you have a reflective surface. From here on, it's a relatively simple matter of covering the silvering with a couple layers of protective paint. This is then baked to cure or set that coating. Underneath the layer of glass, the silvering will never need polishing and never dull. Looking sharp, modern mirror. Hey, thanks for watching this video instead of, say, your own reflection. And don't forget to follow us so you never miss an episode of Owl Connector's General Knowledge.
I could not hear you.
I know the sound was terrible. I'm sorry about that. It's just this TV really needs to be replaced. Okay, so we're going to discuss how mirrors are made today in more detail, but that was just an introduction. I apologize the sound wasn't very good, but did you guys hear the word silvering? Okay.
Yay, champ.
You didn't? Okay, well, we're going to talk about that. But it has to do with what Eamon said about there being something on the back of the mirror. So keep that in mind. Let's review a little vocabulary. You guys remember this is on page 6 of your lab, so please turn in your binders to page 6. Guys, remember you're supposed to get your binder out when you come in and sit down, okay? So we don't have to take up time to do that.
So what can you do at the beginning of the period to ensure that they get them then and not now?
Okay, so turn to page 6. I want to review a few of these important terms. Guys, you need to be silent and looking up here now. So light can exist as particles or as waves. It basically is both a particle and a wave. Particles that travel in a wave. Okay, so make sure you have this definition for light. Particles that travel as waves that can be detected or seen by the human eye. What part of the electromagnetic spectrum can we see? Remember that?
Visible light.
Okay, raise your hand, but good. Whoever said that, that's correct. All right, and then transmits. Remember we have transmission, absorption, and reflection, right? So what does reflection mean? Amen.
It means where the light bounces off of the object, like the sheet, like.
Okay, so it bounces off. So reflection means bounces off. What about transmit? Declan?
It goes through.
Goes through, very good. What's the other option that could happen to the light? Yes, John?
It's absorbed.
Absorbed. What happens when objects absorb light? What happens to the object itself when they absorb the light? Do you remember?
It turns that color.
It has more to do with temperature, is what I'm looking for.
It heats up.
It heats up. It heats up because it collects, as it's absorbing that light, that energy that's in that light wave is actually absorbed by whatever object it hits. Okay, so we have transmission, reflection, and an absorption. Today we're mostly concerned about transmission. So let's be thinking about if the light goes through, this is related to the lab you guys did yesterday, right? So we want to see if light is transmitted or not. So hopefully this will be better. Because the sound is not my favorite. But this one might be different, so let's give it a chance.
Hi, it's Doug. I recently came across this unbelievable video. It was taken at a hotel in Texas, where on the roof of the hotel, they have this pool that hangs off the edge, and it has a glass bottom. Look at this.
Whoa.
Would you go in there?
No.
Would you trust this glass? Someone named Benjamin has a question about glass. Let's give him a call now.
Hi, Doug.
Hi, Benjamin.
I have a question for you. How is glass formed?
That's a great question. It's funny, right? Think about just how many objects around you are made of glass. Without glass, we have no windows, no windshields for our cars, no drinking glasses or eyeglasses, no skyscrapers or smartphones. And yet, it's really not obvious at all where glass comes from. Like, if you're sitting there and you have a table or a desk in front of you like this, that's wood. I'm guessing you know that wood comes from a tree. Or this statue here is carved from stone. You know where that comes from. But glass? Glass is a material that has to be made. How do they make it? Where does it come from? Before I say anything more, now would be a good time to pause the video and discuss. Okay, you ready?
So, what do we know? We've talked about what we know about mirrors. What do we know about glass? Yes, Declan.
It's made from heated up steam.
Correct. And what do we know about it in terms of absorption, transmission, and reflection? We'll go with Eamon.
It transmits light also absorbs a bit. It's like this audio like heat up a bit.
Okay, so why would the glass, which is transparent, right? Why would the glass absorb light? Declan.
Oh, I was gonna say.
Oh, go ahead. What were you going to say?
It kind of reflects. You can't see a clear image, but it reflects off just like regular light. Or
Sorry.
like those cat laser
Am I in
things.
your way?
It's basically that's just like an LA.
Right. Okay, very good. So, what do you guys, when you look at the windows in this room, are they very clean or do they have some smudges on them?
Just a couple.
Okay, what is that smudge made of? Dirt? Okay, is dirt matter? Yes. And so the dirt that's on the windows, if the light beam hits that spot, what will happen to it? If the light hits the dirt, will it be transmitted or absorbed or reflected? Gabe? Reflected, right. So as the video will tell you here now, there are impurities in glass. During the process of making glass, it's really impossible to create it without having some impurities in there. So those impurities can reflect light. So let's finish this video.
Believe it or not, glass is made by taking a bunch of sand and getting it so hot that it melts. It's one of the most amazing things to watch how it's made, because in order to melt sand, you have to use a special type of oven that can get super hot. It's called a furnace or a kiln. Here, you can see someone loading some sand into the furnace. Once it gets hot enough, it will melt or become liquid. And when you get something this hot, you can see it glows, just like lava. This isn't lava though, it's molten sand. And as it cools, it will start to look more familiar to you. It becomes solid glass. To make a flat sheet of glass, like you'd use for a window, they melt sand until it's molten. Then they pour it out and roll it into a flat shape like this, and carefully allow it to cool. More fancy objects, like a glass vase, are even more fun to watch. This involves a special skill called glass blowing. You can see here, it starts with this person taking a big glob of molten sand and hitting it on the end of a hollow pipe. Then she blows air into the pipe. You can actually blow a bubble into it, which might end up being the open part of the vase. The molten glass has a similar thickness as honey. They carefully shape it the way they want it and keep turning it and turning it. As it cools, it becomes solid. Artists can make amazing sculptures with glass. Believe it or not, this artist is making a glass swan. So that's how glass is made. But it's kind of weird, isn't it? I mean, how did people ever discover that if you melt sand, it makes glass? We've been making glass for a long time. So long ago now that no one knows for sure who was the first person to discover that if you melt sand, it makes glass. But some of the earliest objects made of glass come from ancient Egypt, a place covered in
Guys,
desert
let's pay
sand.
attention to the video.
Could it be that someone long ago had a campfire and noticed that the heat of their fire melted the sand beneath it? No one knows for sure, but it's possible. That's all for this week's question. Thanks, Benjamin, for asking it. Now, for the next one.
Okay, so it's made from sand that is molten, that is heated so hot, really, really hot, that it becomes liquid, okay? So anybody else, did you learn anything else from the video besides that it's made of sand? What else did we learn? Declan.
They don't know who made them.
That is a really important point. We don't know who. It's been around for so long, the activity of making glass, that there's no recorded history. So it's previous to probably recorded history. Anyhow, so guys, the making of glass and the making of mirrors is different, right? You see that from the two videos? Did you see the distinction? Let's look at that a little more closely. Okay, so for this part, I'm going to go through, I want you to turn to page 17, and I'm going to point out, and I know it's a lot of words, but we're going to go through it together, okay? Thank you, Chris. So page 17, please be quiet unless you raise your hand if you have a question. Yes, Casey? Can you wait till after instruction? Thank you. Okay, so page 17, making mirrors. You guys can read along with me. Making a regular mirror starts with a piece of glass or plastic. So we have to have glass or some kind of plastic to make a mirror. We have to have a base for it. A piece of glass is transparent because it transmits most of the light that shines on it. We talked about that. Most of the light because it reflects where the dirt and smudges are. So it cannot. So here's the important sentence. It does not transmit all light because there are impurities in the glass as well as dust and other things on its surface. So light reflects off dust, as we discussed, and impurities. And so when it reaches our eyes, we see that light that's reflected off the impurities. Okay. So even though we describe glass as transparent, which means that light goes through, not all light goes through, okay? So keep that in mind. So when we ask ourselves this question, true or false, a piece of glass can transmit all light. Is that true or false? Raise your hand. Amen?
False.
That is false.
False.
And let's look at the sentence that tells us that. Ryder, please stay seated. So we have a sentence that says specifically, it cannot transmit all light because there are impurities in the glass. All right, so underline or highlight that sentence. Just whatever you have in your hand, if you just have a pencil, just underline it. But I want you to point out that sentence so that you go back to it on your quiz. When is the quiz?
Tomorrow?
It is Monday.
Here, there's been Dr. Barkus.
We've only had one quiz this
What is it
quarter.
even going to be on? Ryder, what's even happening?
Hey, guys, settle down. All right, Gabriel, yes, good job.
Not.
It's going to be over what we talked about, water and the water cycle.
That's easy.
I know. No, it's more detailed. It's more detailed. Hey, guys. Listen, it's just going to be a quiz. It's not a test. So we're not having a unit test like we did last quarter, where everything, the whole quarter was on the test. This is just covering what we covered since the last test. So water cycle, we went into a lot more detail with the water cycle. Solar energy we talked about. Please be quiet and sit in your seats, guys. Ryder and Chris, be seated. So it will be Monday. It will not take you the whole time, but if it does, you will have Tuesday to finish it, okay? But you guys need to, so based on that, your water cycle packet that's been due all week, you have to turn it in tomorrow at the beginning of class, okay? So if you haven't already turned it in, if you've already turned it in, there's a score in Power School. Okay, guys. When we're in the middle of instruction, I need you guys to stay seated and I need you guys to be quiet. All right, so looking now at this next portion of text, to make a mirror, a thick layer of smooth metal, such as silver, is added to the back of the glass. This process is called silvering, but it can actually be it's there to protect the mirror, but it can actually be made of other kinds of metals too. So even though it's called silvering, sometimes they use tin, sometimes they use silver, sometimes they use other metals, okay? So all the light reflects off it, okay? So that silvering, that metal will reflect light every time. So that's how you create a mirror, is you put the silvering on the back of the mirror. So any light that actually makes it to the mirror is going to be reflected off that silver. Okay, so when we look at this next question, true or false? Oh, that's still the same question. True or false? A mirror is opaque. Raise your hand. No, Eva.
True.
That is true. It is opaque.
I know.
Yes,
I agree.
Gabriel.
It is true.
It is true. So circle true.
The answer is true, so I don't know if it's true.
I just said it's good.
It's true.
All right. So. Okay, now guys, I want you to read this paragraph to yourself. So there shouldn't be any talking at all. Just this one paragraph and then we'll discuss it. The paragraph on page 18, the next paragraph. You actually have to turn the page to 18 then. So read that paragraph. It's about one-way mirrors. So right now you're on page 18 and you're quietly reading that paragraph.
is thanking.
So you're just reading this paragraph on page 18. You'll have about 2 more minutes to finish that paragraph.
Doing that also helps you with proximity, which always gets kids doing whatever the task at hand is. Just simply walking in.
Did you read it? Yes, me.
If they didn't need their iPad for any of this, what could you have done at the beginning of
Okay,
class
guys.
to make
About
sure
30
that they
more
weren't on
seconds to
them
finish
later?
reading that. Guys, don't be on your iPad right now. You know that you're not supposed to be on the iPad. It says no iPad. So put your binders down, the iPad away. Thank you. All right, so let's look at this together now. So a
Sorry about the water.
A one-way mirror is made by combining a very thin layer of one-way mirror film and a piece of glass.
Yeah, I was sent to this room. You don't need anything.
No.
Okay.
Thank you for checking. Yeah, I don't know about that. All right, so a one-way mirror. You guys remember the one-way mirror? We used it yesterday in the experiment. Okay? Yes, Casey? We're almost done. I'm sorry, I let her go because we were at that moment. So in just a second. All right, the one-way mirror film has special structures. We can't see the structure of the mirror, of the one-way mirror film. We can't see that unless we zoom in really, really far to like the molecular level. Okay? So when you zoom in on a piece of the one-way mirror, we see this. This is a model of a model of what a one-way mirror film looks like. So we have the back part, which is some kind of brace, either glass or plastic, usually glass. And then notice how the silver particles are not covering every square inch of that space. Please don't turn on the water. All right, guys, listen up. So see how it's different here? You have parts where there's silver. What happens if the light hits silver? Raise your hand. Amen?
Doesn't it just stop the lights from going?
So what do we call that?
Okay. I usually get
Opaque. The object is opaque. Chloe and you guys look up here. Gabe. Reflection. Yes, reflection. So when an object is opaque, Chloe and Imani, please stop talking. Thank you. So when you have a situation like this with a one-way mirror, the areas that have picked up the silver will reflect the light. What about the part that's glass? What will happen to that light? Amen?
it transmits.
Transmits. Very good. All right. So looking now at page 18, if you guys look at your page, you will see that we have a diagram here. Your word bank is mirror, window, and one-way mirror. So here you have 3 different scenarios, 3 different examples. So noticing the light coming in, there's 10 lines of light coming in. This is the regular mirror. This is the window, this is the one-way mirror. I'm not telling you which one's which, that's your job now, to match those words to the correct circle. So based on what you know about one-way mirrors, regular mirrors, and glass, you want to answer which one you think is which.
Guys, I'm done.
And you can talk about it at your table. You can discuss it.
Okay. If you're done, then I'll see you guys wait for your friends.
We'll take about 2 minutes for you guys to discuss this.
Oh, yeah, sure. Cameras say yeah. Look at mine.
gotta do that.
Then you can go down. Thanks for being so patient. Here's your pass.
Guys, I am so good at this game. Do you have a crush on Dad?
No, I don't. He is nice. I am nice. I am respectful. I am respectful. I am A+.
Good job.
I like it A+, not any more F.
Good job, kid.
I like things.
Ready, Daddy?
Okay, guys, discuss it quietly. Gabriel, you're sure dancing a lot
You're
today.
the best. You're the best. You're the best.
I think he likes being on video.
Yeah.
I'm like Shakira and a Taylor Swift. My music session.
Nice. All right, let's look at this together now. What did you guys put for the first circle? The first circle, it has a layer of paint, and then a whole layer of silver, and then a glass layer. Declan, I saw you first.
Yes, okay, it is, mirror, a mirror.
It's a regular mirror. Okay,
So when
don't
you say
stand on that
discuss
stool like
quietly,
that.
what does quietly mean?
How about the next one? How about number
Quietly
2?
is no.
Gabe?
I discuss quietly. That might want
Okay, you guys, listen. There's someone talking, so you need to be listening. Go ahead and say that again, Gabe.
The second one's the one-way mirror.
The one-way mirror. Okay, so let's look and see how that is. So we have the light coming in from the light source. We have a glass layer. Notice how we don't have a layer. Amy and Allie, group 3. All of you guys turn around and face front. You need to be paying attention. So your answer was one-way mirror, and that is correct because we have a situation, we have a situation where we have the glass and we have the one-way mirror film. What would this be? Eamon?
It would just be
Just plain glass, right? That's just plain glass, but notice on that picture, guys, see the representation of the impurity? Remember that there are impurities that get trapped when the sand is melting? Oh, thank you very much. Okay, so what's the last one then? It's all together now? What's the last one? Window. Very good. Okay. All right.
I know what you're talking about.
Now turn to page. You guys need to settle down, group 2. Turn to page 19.
Wait, is it a big deal? I put glass for the window.
You can erase it and put it correctly. It matters that you have the correct answer, yes. Yes, Ryder. Oh, what? About 4 more minutes. So guys, we have about 4 more minutes. So I want you to work on page 19 on your own individually. And then when you have finished recording your answers, we'll discuss it, okay? So your directions are, if 10 light rays shine on a mirror, a one-way mirror, and a pane of glass, what's going to happen? So you literally want to draw arrows where you think those 10 light beams are going. Are they transmitted, reflected, or absorbed? So for each of the arrows, you should have a line that continues from the arrow that shows what happened to the light. So tomorrow, we're going to be doing another investigation. We're going to be doing another experiment tomorrow. We want to make some predictions. What's another word for prediction? Amen.
Hypothesis.
Hypothesis. Declan. Imani. What is a hypothesis?
I know.
Do you remember?
I know.
Okay, hold on. Is it a statement or is it a question? It's a question? Okay, that's fair. We haven't talked about it for a minute, that's why we're reviewing, because guys, the scientific method never goes away. It's critical that you understand the scientific method, all right? So the hypothesis is a statement that, Antonio, a hypothesis is a statement that your experiment is based on. Okay, so we're going to make a prediction, and then tomorrow we're going to collect the data and get the answer. So the first question is, how does light travel? In a straight line or curved lines? You need to make a prediction of what you think the answer is to that. It's a statement. Can light change direction? Again, make your prediction. It's a statement, not a question. And then third, do one-way mirrors transmit and reflect the same amount of light? The same amount of light. Okay, so fill out your predictions, and that will be it for today. I want you guys to all fill out the predictions. I'll come around and help you individually. But you want to do your work too, Gabriel. I know you do.
I'm doing well.
You're doing well.
What are you doing? Prediction.
Well, I'm going to do like second grade. Make a prediction. What do you think light travels in a straight line or just curvy? So you're going to pick one. But remember, it's going to be a statement. Yes, go
Stuff was so like the last had to do it. In this age, I was so good.
Okay, so you
I hate
go ahead and write light.
I just hate like
Prediction. Yes, light and
It's your favorite song in the world. Shake it off. Get away from I can do this. I am right.
So guys, you should have a prediction for each of those three questions. Remember, it's a statement and you need to write a sentence.
Light changes direction. Yes, it can. I don't know what to do for a prediction.
Statement, which is a sentence. So you're going to say light travels in a straight line. That you want to be able to say, yes, that's true, or no, that's not true. Okay? So your hypothesis always needs to be either supported, where you say, yes, that is true, or negated, where you say, no, that's not true. But it's always a complete sentence.
Light travel. Does light travel in a straight line? I don't know what I would write my pen.
Hey, I'm an English teacher. Want me to give you a trick? Use the question you answer. Statement. Super easy. Then you have to think of your own sentence. Use theirs.
Yes.
That would be another good time to give some tickets. Reinforcing those behaviors you want to see. Students that are on task and engaged, completing work, thanking them for being engaged, for doing what is asked of them.
You haven't
have
turned
we
in your
talked when we're
water
talking
cycle
quietly
packet
men?
yet.
To me, that's
You
an
have not.
oxymoron. To you, it might mean something
Okay, guys,
different.
give me your attention for
What
one
do you think
moment.
it means for them?
Raise your hand if you have turned in your water cycle packet. Raise your hand if you have turned in, guys.
I'm turning my water cycle packet.
Okay, good.
And grade it for me. I'm reading it.
If you don't have your hand raised, and you need to do that by tomorrow.
It becomes a pillow then, huh? For Dr. Barkus. She's in college and needs to do this as an assignment.
She's an amazing teacher.
Awesome.
Oh yeah.
What time is it? You're dismissed. I'll see you tomorrow.
What do you think about Dr. Barkus's class?
Yes.
What do you think about it?
Go.
You are such
Yeah,
a
it's
good
good.
dancer. I tell you. I wish I could dance like that.
All right, you might have a future in dancing.
Okay,